Don't laugh, that's mine. How can you laugh? Okay, so can we start?
Yeah.
So, what is the next one?
Layers, both.
So, in the previous, can you go back to the slide, please?
You don't have any.
Yeah. Okay, as you can see, it will go to the router after here and transmit. Okay? Do you have any information with this part? The transmission will start from here after anything is over.
Yeah.
It's slide number. Which slide? Number 16. Okay, and next one. Oh no, slide number 22. So as you can see in here, we've got frame here. Data. For example, TCP, the IP address, and Ethernet. So this is the thing that we're going to put on the line and transmit it. Okay, so the first part is for L4, this is for L3, layer number 3, layer number 2, and layer number 1. We call it data, we call it segment, we call it packet, and frame. So this is data, this is segment, this is packet, and all of it is frame. Did you understand that?
Yeah. Okay. All of it is frame.
Yeah, all of it is frame. So the first one that generated in layer number 4, who's generating this part?
User.
No, application. Such as Internet Explorer. So we call it data. When we go to that third layer and we use the operating system, we're generating segments. Then we're using the second layer for generating a packet. So this is the packet with the IP address, and then the whole thing is frame, and it will be 0, 1, things like that, and we transmit it. Any problem? No. Segment is not this part, it's this part. Packet is not this part, it's this part. Frame, the whole.
Yeah, okay.
That's the point. Next slide, please.
Layers with TCP/IP and OSI.
Okay, I already talked about TCP/IP, and we've got a thing you have to know. The protocol model provides a model that closely matches the structure. Why we divide the protocols like this? This is for TCP/IP. For TCP/IP protocol, we've got OSI protocol is the same as this one, but with different sequence. But generally it is the same. Which means that we've got 4 standards. One standard for the user interface, one standard for operating system, one standard for transmitted through the WAN, one standard is using your Ethernet. So for the OSI, you have to get these 4. But the first one could be anything. You can call it carrots if you want. So it doesn't really matter for us. So we are modeling our protocols. We are modeling, dividing. For example, we are modeling BTH. We've got electric, faculty. We've got math faculty. We've got things like that. Next slide will be, I will talk about the OSI. Okay, in OSI we've got 7 layers. In here we've got 4. In the OSI, we've got the application, presentation, and sessions, the same as application layer in TCP/IP. Then we've got transport, the same as this one. Then we've got network, the same as this one. Then we've got data link and physical, the same as the first layer. They're just some names. Okay. Next slide will give you the full picture. So here divide by 3. Let me just raise this up. Do you have any problem with this? Do I need to draw it here, or you already know it? Huh?
Which one?
The slide.
No.
So the fourth layer in TCP/IP is divided in 3 parts in OSI. What is the first? Presentation. Then session. Then transport.
No, it's application. Presentation.
Application. Okay. And the application, you're right. Doesn't matter. Okay. Then the same here, and physical in here, and data link, I think. The same things in here. Network and transmit and network. Transport and network. Okay? So, I mean, if you know what's going on here, if you know what's going on here, it would be the same for, what was the first thing? Application. So the application is the same application that we've got. We've got presentation. The part in OSI who presents you the information. And we've got sessions. What is session? I'm talking to you, and there would be a session. Each sentence would be one session to you. Okay? And it is the same data link and physical. Data link is divided for, I don't know, the hubs and switch, and physical is the cable. But in TCP/IP, this is 1. In here, this is 2. It doesn't really matter. If you know the rule, it would be the same. Can I answer? Yes or no?
Yeah.
Yes. Okay. As you can see in here, explain how labels and encapsulation. What was encapsulation? This was encapsulation. Can you remember the part? It was encapsulation. Divided to data, segments, packets, and frames. So that's encapsulation. So, as I said, we've got physical layer here for timing and synchronization of the bytes, of the beats. What does it mean? Timing. I'm start talking at this moment, from this moment, so you know when the transmission is start and when it will be over, and it will be synchronized. You will understand where I'm starting my sentence and when it will be finished. Then we've got another part called data link. It's destination and source physical address. So let me tell you something here. We've got physical address here. Physical address is